Lewis dot structures and covalent bonds. What is the Lewis dot structure? The Lewis dot structure was named after Gilbert Newton Lewis. They are a symbolic representation of atoms and their valence electrons. As you remember, the valence electrons are located at the valence shell, the outermost shell.
There are two main components of a Lewis dot structure. The element symbol, which represents the nucleus of the atom and all its filled inner shells, and dots, which represent valence shell electrons.
Let's try it. We will be using oxygen as an example. Oxygen has 6 valence electrons. First, we will need to draw our 2 electrons for subshell 2s. Now, let's add our remaining 4 electrons belonging to subshell 2p. And our Lewis dot structure is complete.
Uh-oh!
Why is oxygen so sad?
Oxygen is unhappy because his valence shell is not completely filled and now he can't be at peace. He wants 2 more electrons to fill his valence shell, just like his friend Neon. This is Neon, and he is happy because he has 8 valence electrons in his outermost shell.
Covalent bonds occur when 2 atoms share 1 or more pairs of valence electrons. There are 2 types of covalent bonds. Polar, which are any covalent bond with electronegativity difference between bonding atoms between 0.5 and 1.9, and nonpolar covalent bonds, which are bonds with an electronegativity difference of less than 0.5.
Back to our friend oxygen. Oxygen is looking to add 2 electrons to his outer shell. Suddenly, he sees somebody who might be able to help. The hydrogen twins. The twins each have 1 electron in their outer shells, and are looking to add another. At this time, they aren't really getting along, so sharing between them is a no-go. There could be a way to make everybody happy here. Oxygen can form a covalent bond with the hydrogen twins, and each element subshell will be complete. Let's see how that looks using the Lewis structure.
First, we will need to add up their electrons. Between our 3 atoms here, there are 8 electrons. Now, we would choose our central atom and determine connectivity. This you will sometimes have to figure out. Other times, you will be given the experimental one. The central atom is usually written first in the formula.
Looking happier already! We'll connect our atoms using lines to depict the single bonds. Each line here represents a shared pair of electrons.
We have a total of 4 electrons, which means we have 4 left. This is the perfect news for our friend oxygen. Dots will be used to represent the remaining valence electrons.
Now, our oxygen has 8 electrons needed to be happy, and our 8 hydrogen twins are at peace. And we have created a Lewis structure for a H2O molecule.